Oh, so now, yeah. All right, guys. So I think we're ready to go over this, maybe? Oh no, where'd my stylus go? Here it is. There. So first thing is our given. We want to go through our given, and it says that OM is perpendicular to LN. What can we conclude if OM is perpendicular to LN? That angle 1 and angle 2 are what kinds of angles? Right angles. So that is our second step. So we need to mark this, and then we need to say angle 1 and angle 2 are right angles. And now we need our reason. Well, we go back and we say, well, it was the perpendicular part of the given that made us come to that conclusion. So what is the reason here? Def of perpendicular. You got it. And now remember, after we declare right angles, what do we always say that those right angles are? Congruent. So step number 3, we need to say angle 1's congruent to angle 2. Right angles are congruent. Okay, now let's keep going through the given. They said that LM is congruent to MN, so I need to mark that. And what I want to prove is always written last. So my last statement is going to be triangle OML is congruent to triangle OMN. And remember, our reasons for proving triangles congruent are either side, 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 side angle, side, or angle, side, angle. So right now, I only have from the given information that I've concluded one side and one angle. So we need one more thing, and they're giving us a clue that's saying it's reflexive. So what here is the same thing in both triangles, Leilani? Segment OM. You got it. Segment OM is the same in both triangles. So we're going to say OM congruent to OM reflexive. So now we look at our markings. And that's why it's so important. Now, do you guys understand why since the beginning, chapter 1, I've been stressing about the markings? Because if we don't mark it, we won't know which method it is. So now, which method is this? Side, angle, side, SAS. Okay. So now what we're going to do is in proofs, we're going to go past proving triangles congruent. Once we're able to have two triangles congruent, what does it mean about those triangles? If I say two triangles are congruent, what does it mean? Those triangles are what? Don't know. The same. Their side lengths that correspond are the same length. Their angles that correspond are the same measurement. Everything about them is the same. So I'm asking you, suppose that I tell you this triangle ABC is congruent to triangle DEF. Is it true that I can say angle B and angle E, which are both the middle letters, have to be congruent? Is that true? Absolutely, that's true. So yes. So now what we're going to do is after we prove triangles congruent, then we could say any angles that match up, that correspond, or any sides that correspond will also be congruent because the triangles are congruent. And in proofs, we're going to write that as CPCTC. That's going to be our reason, CPCTC. And CPCTC stands for corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. Corresponding parts of congruent triangles are congruent. But luckily for us, all we have to do is write CPCTC. Okay, next thing we're going to talk about are circles. A circle is named by its center. This circle is called, so the way we shortcut it is we're going to draw a circle, put a dot in the middle. And then you put the center point here, which is P. So this would be called circle P, capital letter P. And circles are really special because the distance from the center point to any place on the rim of the circle is the same distance, which means these segments are all congruent. So any segment from the center to the rim of the circle is going to be the same length. Does anybody remember from middle school what that segment is called from the center to the rim? A radius, excellent. So a radius of a circle is a segment joining the center of a circle to any point on the circle. So I'm going to take away my extra. So right now, from this diagram, can somebody name me the 3 radii that were drawn in our initial diagram? What's one radius in circle P? It's one radius. Stella? Yeah, segment PA. So radii are always segments. So segment PA. Can somebody tell me another radius that's drawn? Jack?
PB.
PB, perfect. Can somebody tell me the third radius that's drawn? Sebastian? PC, perfect. So how do we identify a radius? A radius has to start at the center point and just go to the rim of the circle. That's it. That's how we identify it. Now there's a theorem. Since every radius from the center to the rim has to be the same length, how do we in geometry terms say that they have the same length, that they are congruent? Exactly. So there's a theorem that says radii of a circle are congruent. We need to memorize this theorem. So you know how we say right angles are congruent and straight angles are congruent? Now we're going to say radii and vertical angles are congruent. Now the next one is going to be radii of a circle are congruent. No, it could be any order. All right, let's do a proof. So in the given information, I tell you circle P. Anytime I tell you in the given information the circle, I want you somehow to tell me radii are congruent. So because it's circle P, in the next step, let's name all of the radii. Can somebody tell me 2 radii that they see? Jack? Good. So I'm going to say PA is congruent to PB, which is also congruent. Can somebody tell me 2 more radii? Kate? You got it. Congruent to PC, which is also congruent to PD. Do we agree that all 4 of these segments have to be congruent because they're radii? And the theorem says all radii of a circle are congruent. You got it. Okay. Can I say, so now I went through my given, I made conclusions. So now I want to look at what I need to prove. I want to prove that AB is congruent to CD. Can I say AB is congruent to CD also because all radii of a circle are congruent? Can I say that for A, B, and CD? No, I know they're not radii. How do I know they are not radii? Leilani?
The segment given the center of the circle made out line is measured.
Good. A radius has to come from the center. Do these come from the center? No, so they're not radii, so I can't say they're congruent. So as of right now, there's nothing from my given information that leads me to be able to say that they're congruent. But aren't they each part of a triangle? If I'm able to get the two triangles congruent, aren't every part that matches up also have to be congruent? So this is my goal right now. When I can't prove what I want from just the given alone, I'm going to prove the triangles that they're incongruent and then use CPCTC to say that they're congruent. So I know my last step is going to be CPCTC because I need to get the triangles congruent. And after we get the triangles congruent, then we could say parts of those triangles are congruent by CPCTC. So now I need to get these triangles congruent. Well, there's three ways to get triangles congruent: side, 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 or angle, side, angle. Right now, I have two sides, side, side. I need something else. Does anybody see anything else that we can say is congruent? What if I tell you it's going to be an angle? Does that help?
Wait, what was the question?
What else can we, because we need to get these triangles congruent, but all we have are two S's. I need something else. I need an angle. Let me tell you that it's an angle.
That's like where to
Yeah, we have the vertical angles. We have the kissing birds, guys. Can I number them 1 and 2 if I wanted to? Yeah, I'm going to do that. So I'm going to say angle 1's congruent to angle 2. So angle 1's congruent to angle 2. And the reason's going to be vertical angles are congruent. Now, can I say the triangles are congruent? Yeah, so I wrote triangle CPD. So we're going to match that up. It doesn't matter, actually, CPD. I'm going to say APB. And what method are they congruent by? Leilani? SAS. And now, which I predicted this, now that the triangles are congruent, don't A, B, and C, D match up in the triangles? They're called corresponding. So their sides are corresponding. So they have to be congruent by CPCTC because the triangles are congruent. So that's what CPCTC does. After the triangles are congruent, any pair of sides that match up or any pair of angles that match up also have to be congruent. And the reason is always CPCTC. A little bit different, right? But we got this. Let's do another one. Here we have angle in the given information AEC. So I have to mark this. AEC is congruent to DBE. And then we have BE is congruent to CE. And I have angle 4 is congruent to angle 5. Hi. Thank you. Luciana, have you been watching the videos? Great. Okay, I want to prove that AB is congruent to CD. Right now, from the given information, there's absolutely no reason I can say A, B, and CD are congruent. But are they part of triangles? Yeah, they're both part of triangles. AB is part of this triangle right here. And CD is part of this triangle right here. So if I'm able to get the triangles congruent, Then after I get the triangles congruent, can I say A, B, and C, D have to be congruent because the triangles are congruent? What does that? What is the reason that we can say segments are congruent or angles are congruent? Because the triangles are congruent. What are those letters that we put together? What is it? The reason. So it's after we prove triangles congruent, we say segments that correspond are congruent or angles that correspond are congruent. What's that reason? CPCTC. That's the reason. So after we prove triangles congruent, then any pair of sides that correspond or any pair of angles that correspond, we're able to say are congruent, and our reason is CPCTC. Okay, so first we have to work on getting these triangles congruent. Well, the nice thing is, out of these triangles, I already have the side EB from the given, and EC, and I have angle 4 and angle 5. So I have one S and I have one A. But these top angles that I marked, aren't they too big? I need angle 1 and angle 3. Any guesses on how we're going to get angle 1 and angle 3 to be congruent? Jonah? Excellent, subtraction. Don't they overlap, those two big angles at 2? So because I'm subtracting that 2, I'm going to say angle 2 is congruent to angle 2 reflexive. And then I can say angle 1's congruent to angle 3, subtraction. So now I got angle 1 and angle 3 congruent. So then I wrote triangle EBA. If I wrote triangle EBA, how are you going to match up the other triangle with the right letters? Caitlin? Excellent. ECD. And what is the reason? Is it SSS, SAS, or ASA? Which one of these is it? Noah? ASA, you got it. What's the last thing we always write in our statement, I should say? What's the last thing we always write in our statement? What we want to prove. Don't we want to prove AB is congruent to CD? All right, now that the triangles are congruent, I can say AB and CD are congruent. What are those letters? You got it. CPCTC. Corresponding parts of congruent triangles are congruent. Can I ever use CPCTC before I prove triangles congruent? Never. We can never use CPCTC before we prove triangles congruent. We only use it after we've proven triangles congruent.
So like the last thing first.
We could do beyond CPCTC, so it's not always the last statement, but it's always just after we prove the triangles congruent. All right, we're not gonna, I guess we can do the overlapping. Okay. Let's do number 3 together. So we have circle O. And remember, anytime I tell you circle, I want you to tell me that radii are congruent. So based here, and obviously it's always linked to triangles. Does anybody see 2 radii that are also sides of triangles? Stella? So OP is not a radius because remember, a radius has to start at the center and go to the rim. P is not the rim. You're right. OR and OK, they are radii, but are they full sides of a triangle? Do you see another set of radii that are full sides? Good. I'm going to go with that. OS and OT. They have to be congruent. And look at statement 2. Doesn't it say OT and OS are congruent? Who remembers the reason why we're allowed to say these radii? Leilani? Congruent. Good. Radii of a circle are congruent. Okay. So then it says angle T is congruent to angle S. So I'm going to mark that. Yeah. No, we have OK and we have OR, but are they sides of triangles? If you did put it, it wouldn't be wrong, but it's not helpful to us. Okay, so now we have a side and an angle. Let's look at what we want to prove. We want to prove that MO and OP are congruent. As of right now, they're not radii because they don't touch the rim. So I cannot say OM and OP are congruent. Since I can't say MO and OP are congruent, guess what I'm going to do? Prove triangles. Good. We're going to prove triangles congruent. Which triangles do you think we're going to prove congruent? Which triangles do you think we're going to prove congruent? Jack? Those are angles. So triangles with 3 letters. You got it. I'm going to prove triangle TMO and triangle OPS. So right now I have a side and an angle. We need one more thing to prove these triangles congruent. Who sees another part that we can say to prove these triangles congruent? Remember, we need side, angle, side, 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 or angle, side, angle. Looking for somebody new. What if I tell you the last part's going to be an angle? Yeah, Bella? Yeah, angle 1 and angle 2 are congruent. Why, Bella? Perfect. Remember the kissing angle, guys. So we're going to say angle 1's congruent to angle 2. Vertical angles are congruent. Now, do I have enough information to say the triangles are congruent? We do. So I'm going to say triangle TMO is congruent to triangle SPO. And which method are they congruent by? Noah? ASA. And now our last step is going to be that MO is congruent to OP. Who thinks they know this reason? Stella? Good. CPCTC. Can, yeah. TNS? They were in the given. See right there. Can somebody explain to me how we use CPCTC or when to use CPCTC? Stella? Good. After we prove triangles are congruent, we could then say any pair of sides or any pair of angles that match up or corresponds are also congruent, as long as they're inside the triangles. Okay, I'm gonna decide that we're not gonna do overlapping triangles. I want you guys all to try number 6 on your own. Maybe next class I'll show you an overlapping, but I think this is enough for today. So you guys are trying number 6 on your own, and maybe next class I'll show you the overlapping ones.
Should we show you what the day? Yes, please. I don't know if you want to make sure when you're saying the triangle, because you said there has to be like a certain order, would this be like wrong? Because it's like,
So I didn't catch that X, Y, B, then we would have to say X, C, B. So if we said X, Y, B for the first one, then it'd be X, C, B for the second one. So the first one doesn't matter, but you have to make the second one match the first one. If that makes sense. Let's do this. What do we bisect? What is this, the other symbol? So if we bisect an angle, we get angles, right? So we go to the middle letter, so 2 angles by X. So those are equal to on this side. Oh wait, but that's not the limit between, oh yes, we're better. Then I would say 3 and 4, when you went to the race, well, what would you mark them out? So what's that inside? You know, never writing is right.
yeah, sorry.
Yeah.
Yeah. Where's one like, I didn't know.
Oh my God, now it's it's fun.
Let's do it, but he says like, it's like, no, hold up, keep your information like.
Okay.
We're like, the like wire, but I just have to remember like the AS, like that stuff goes seconds a lot. So, and because of that, that's why I keep everything. Well, then what are we doing? It's just something. So now, oh, erase was related. Imagine if I could have something like, yeah, you want 2 angles. So it's like something else here, and you just have to here. Because then I know they do it. It's like, there's some communication, such a smart state. Yeah.
So there's no precision, right?
But there are, now they would state, on this side, this seems, I didn't know. Yeah, not really. I just which of the, yeah, the whole idea. Look at you, just like that's like, it's just like attraction problems or like say that, because they like this and that. And just your problems, there was an X, it's just the right XB is a flip side.
See how this is the same side of the so they're sharing side. So you say X, B, and X, B.
It was like, when I saw it, when I was like, oh, okay. Wait, are we done or are we doing it?
Yep, then you're done. Once I check you, you're done. Leilani, could you go check the book? Okay. Oh, yeah. Okay, yes, so now that an X there. So now you check to see if the triangles are congruent.
Oh my gosh.
You're going to are.
My thing.
So now we write the triangles are congruent. You do triangle symbol, and I'm gonna show you.
Wait, how do you segment for number 2? You're saying XB bisects the angle.
Okay, just don't forget your.
So I just thought like what I got. I got the
And then by what method are they congruent?
like angle 1 and 2. Instead of sections. Oh. It's. I sorry, what did you say? So, I keep putting the move one thing into this folder. I need to do that. Yeah, I know, I know. Yeah, I do it. It's like, yeah, I'm not together. And the only thing she sees is like the review, so I get it. But I always think that that or that and not.
I thought you were gonna.
Oh, sorry. I did. We need to check them out.
Perfect. You're doing good. Okay, so then like there's, we wanna make sure you mark up the diagram, so if the one can, for example, 2, let's put that. and then your length was x. Now, to prove triangles congruent, there's 3 ways to prove triangles congruent. Remember, there's SSS, SAS, or ASA. And you always go by how the markings look. So see how this is angle, A, and then a side, and then an angle. So these triangles, this one and this one will be congruent by ASA. And then we write the triangles to draw a triangle symbol. And then you have YXB. And then you just say your relative and then draw another triangle. And then you match up the other side. So I said YXB, so that means CX. Sure. Still, like, we still do different, like,
If I just remembered you this once.
Well, like, I don't think no, you guys like nobody ever said anything more. Like, I'll put kind of like,
All right, let me post the homework for you all. Oh, stop.